Welcome to the ISF podcast from the Information Security Forum. The ISF podcast is hosted by ISF CEO Steve Durbin, and every episode he brings listeners features timely conversations, practical insights, and resources for global cybersecurity professionals. I'm producer Tavia Gilbert. Today, Steve speaks with Dr. Ellie Pavlick, a professor of computer science at Brown University in Providence, Rhode Island, whose research focuses on computational models of semantics and pragmatics which emulate human inferences in artificial intelligence. Steve and Ellie discuss generative AI, developing a pipeline of talent to work with it, and perspectives on its developing uses for organizations.
So, Ellie, thanks very much for joining me on the podcast today. Great to see you.
Yeah, thanks for having me.
I wanted to talk to you about artificial intelligence primarily today. It seems almost as if not a day goes by and not an event do you go to without somebody asking questions about artificial intelligence, normally started by what do you think about ChatGPT and so on. But before we get into that, just tell us a little bit about your career, because you're a researcher now at Google AI, right? And you've been involved in this kind of thing for quite some while. So help our listeners to get an understanding of how you came to be involved in this space.
Yeah, so I'm a professor at Brown University in Rhode Island, and I also work as a research scientist at Google in a kind of part-time capacity. So I've been working in natural language processing. I started my PhD in 2012, although the field is very different 10 years ago than it is now. It's been a very interesting time to, I think, enter the field and just be in that kind of early career stage when like everything is changing so quickly. But yeah, I did my PhD in computer science and in natural language processing, and then did a postdoc at Google after I graduated, and then have been at Brown since 2018. And really, I think like all of this stuff we're talking about now, like the kind of early rumblings of the kind of technology we're looking at now, kind of around 2017, 2018. So that period, really me starting my career here, has overlapped exactly with this huge shift in the kind of technology we're dealing with.
So I always used to talk about, artificial intelligence as being nothing more than machine learning, probably going back, I don't know, just even a couple of years. And I always used to say that we weren't really at the point where machines were able to think things through and make decisions and what have you. Well, what is your assessment, though, over those last few years? Because as you said, it's been a really exciting time. The whole industry has matured phenomenally, nowhere near full maturity yet, of course, but well on the way and has made huge advances. How have things changed just over those last 3 to 4 years?
Yeah, that's it's interesting you say like haven't been able to think things through, because I think what's kind of very much being debated by people in this field and actually about society at large, but especially like people with their hands on the technology, close to technology, is like whether what we're witnessing is a fundamental shift in kind, like whether we're dealing with things that are fundamentally new, or if it's really just a better version of the kind of stuff we've had. And I think people aren't quite sure, right? Like we're not quite sure whether something deep has changed, or if a lot of the successes are kind of maybe look better than they are under the hood, just so to speak, right? So there's a lot of, you would think that, experts all know how the machines are built, they know how they're trained, they understand how it's working, and so we should all agree on kind of how to interpret it, but that's actually not the case. Like I think people aren't entirely sure how to make sense of the kind of qualitative jump that's happened just in the past couple of years. And so I guess I should say, so you kind of mentioned machine learning, like I think machine learning has been the way people are approaching artificial intelligence really since 2000, right? So for the past 25 years, that's been the dominant way that people are approaching things. There's lots of different types of machine learning. The neural network, deep learning, like flavor that's dominant now has been kind of there the whole time, but wasn't always the dominant one. And the kind of shift we've seen more recently, it kind of started in computer vision more for things like face recognition, and then switched into natural language processing, and that's really blown up in terms of just how impressive the results of applying that kind of idea to natural language processing. So that shift has kind of happened more recently, and really it's been associated with just scale, like having a lot more data, much more and bigger computers to train them on so that you can just train really, really big models that can crunch through a lot of data. And so I think that's why people aren't entirely sure what we're dealing with, because on the one hand, it's like, well, we've had this technology, really the core ingredients for a while, And there hasn't been a brilliant insight. It's just the things have gotten bigger, but when they've gotten bigger, there's been this huge qualitative shift in, like, I mean, that's what people are experiencing when they talk ChatGPT. It's like, wow, something seems so sci-fi. And so I think that's still not completely, like, there's not really agreement on exactly how much of what we're dealing with is new in a profound sense technologically versus new in terms of the availability of it and the applications of it, but similar technology, something we need to come up with new tools to handle versus can use similar existing tools to handle. Like, that's all kind of still being discussed.
I think one of the things that people ask me to try to explain, and frankly, I do a pretty poor job of it, is why is it that, given, as you've just pointed out, we've had this sort of whole development, everybody's had access to looking at the way that it's been moving, why have we now found ourselves in a situation where we've got these almost two opposing camps as to the way things should be going? So you've got the Bill Gates crew on one side, and then you've got Elon Musk and Steve Wozniak and a number of others on the other side. Two very different perspectives, perhaps, on the way in which artificial intelligence should be allowed to develop. How have we arrived at that point, do you think? What's really sparked that?
Yeah, I mean, that's a great question. I think a lot of the analysis of that has to do with more than the technology, right? There's like a lot of interesting kind of political and business dynamics that factor in. I mean, I think maybe the one thing that people agree on is it feels like some kind of an inflection point, right? Like there's, so models like ChatGPT have kind of been around in academic circles for a while. Suddenly it's in the public eye and everyone can feel that shift, right? Like everyone's like, okay, this is something. It kind of surprised, I think, the world how capable the models seem to be. And so everyone can tell, like, okay, something changed. And I think maybe it's fundamental personality difference or something, whether you see this inflection point as ultimately a good thing or ultimately a huge risk. And I mean, it's probably both of those things in superposition, right? And so it's somewhat how people are placing bets, how much they trust society to do the right thing. I mean, I talk to people, like we're just talking in among kind of academic circles, industry circles, you hear people the full spectrum, and you hear people who go back and forth between days. I personally go back and forth between days into whether I'm more optimistic or more pessimistic. And I think it's probably healthy that there's that mix. But like, yeah, I think it just reflects the fact that it's not obvious what exactly to make of this, what exactly it means, what kind of a change we're going to see from it, right? There's also a camp that's like, maybe it's all purely hype. Like people sometimes talk about things like the metaverse, which seemed like maybe we were poised to completely change all of society and hasn't panned out into the type of thing that people thought. So there's also that camp too. That's like, let's all just take a beat and maybe in a couple of years we'll like look back and be like, remember the generative AI phase? We all sure thought that was going to be something and nothing happened. I don't really take that opinion, but that's an opinion too, right? So like really people just don't know.
I think one of the things that people quite often talk to me about is the fact that because we've got an area of technology that is developing, it's not at this stage of maturity yet. And to your point, we really don't know how it can further develop. The whole concept of regulation, policy, managing of how it goes forward is as yet also to develop. Now, regulation, legislation
Right.
is always going to lag the market necessarily, so some might say. But that certainly, I think, is one of the areas where people sort of point and say, well, hang on a minute, how do we regulate going forward? How do we know what we ought to be regulating going forward? Is that something that concerns you?
Definitely. I think like most people I know feel there needs to be regulation, right? Like even, especially people working on technology tend to want some regulation, just some reassurance that someone's thought this through because like there's always that feeling like we don't want to mess this up badly, right? Whatever
Hmm.
that might mean. And it's a lot of pressure to think through what that means. And so I think people like the idea of outsourcing that to like a trusted authority, right? Like rather than individual technologists having to make those calls. And so I think everyone kind of supports the idea of regulation. Well, not everyone, but generally among like, again, kind of research, academic, technology, and a lot of industry circles, I hear a lot of support. The thing that's always so hard about it, and I've talked to a lot of students about this, is like just the people with the right skill set don't really exist. Like this is the definition of there's now a demand for a particular type of job that nobody's really been trained for yet, right? Because the people who are trained who understand the technology well are people with like PhDs in computer science and really no understanding of any policy, legal, anything, right? Like that's just not the training that someone will have had who now understands like it understands at a level deep enough to be able to say that's the type of thing we can guarantee, that's the type of thing we can't guarantee, that's the type of thing that it's reasonable to regulate, this is a type of measurement that makes sense, right? Like that requires a pretty good understanding of the technology. Meanwhile, people with a policy background getting caught up to speed, like there's a big barrier to understanding this technology. I think the things have advanced very quickly, and the machine learning models, like they're not like you don't need to have done super advanced math necessarily to understand them, but you need a decent amount of intuition, right? Like it's not, I think, as always intuitive as some of the earlier AI systems were. So there just feels like a higher barrier to entry, I think. And so I think that's going to be really challenging is just I know a lot of students, like undergraduate level, who are really interested in this area. And I would guess that in 5 or 6 years, we'll have people coming out who will have taken the interesting mashup of courses and things that they need for the background, but then they'll need some years of like internships and on the groundwork. So it's like we're talking about almost like 8 years out before you have people who are really steeped in it that you would really say these people are experts and can do it. But I think we need stuff sooner than that. So I think that's kind of what we're dealing with is like not having particular people with the background that you would want for this. And so instead having to build these kind of coalitions of people with different skill sets, and that just takes time. There's a lot of finding common ground, figuring out each other's lingo, figuring out how to work together.
Yeah, I'd agree. And I think, you make an interesting point that we don't have enough people yet who fully understand it. And yet, on the flip side of that, just recently, for instance, Arvind Krishna, who's CEO of IBM, was saying that they were pausing their hiring for about something like almost 8,000 non-customer facing roles because he felt that they could be replaced by artificial intelligence within the next 5 years. Now, so he's sort of one of the people who's sort of saying, okay, we can replace some of these in a very short span of time, and yet you're saying it's going to take us a little bit longer than that to have sufficient people who actually understand some of this technology. And I think that's where some of the concern comes from that I certainly hear, that perhaps these two things are out of kilter. There's a lot of enthusiasm for what it can do, but at the same time, have we got enough skill set, understanding, knowledge, call it what you will, to be able to really effectively manage some of these transitions that perhaps we would like to make?
Yeah, I'm always surprised to hear how ready companies are to replace people with the technology. From my perspective, it just seems so poorly understood. And I think, I mean, basically, it's hard to make the risk benefit calculation right now because I think so little is understood, right? So you'd have to be guessing about a lot of things. So I guess companies have their risk appetites, and maybe that's the kind of thing. But I think it's a very strange time because of this. Like, I think especially like technology companies in particular are just hurting for other reasons unrelated to AI, right? And so these two things are like happening in parallel. So there's like on the one hand hiring freezes, and on the other hand these like frenzies to find people with this new expertise. It's just a bizarre climate. I think that like what you're saying, people thinking about replacing certain jobs with this technology. This is the kind of thing where for me, having the person to like appropriately calculate the risk, that's the kind of thing where you would need more expertise than people at these companies currently have, right? Because it's kind of hard. There's like, security types of risks. Like if these models are attached to the internet and they're hooked up to internal data, just the risk of something getting hacked, something getting leaked, like we don't really have a really good handle on that. And also we don't have really good solutions for it yet, right? Other kinds of just brand risk, like them going badly, we just don't, like there's still a lot of work on like for stopping them from just kind of going rogue, like we saw the Microsoft Sydney incident, right? Those kinds of things, which depending on the company, like that can have bad effects. And there's probably a ton of things we haven't just anticipated yet because it's so new. So I think if they're really widespread, a ton of companies are using them to replace a ton of jobs. I guess we'll just see it play out in real time, but there could be some pretty bad brand risks and security risks that'll be pretty public. I don't know. I would be hesitant if I'm not a CEO of a company. I would be hesitant to like quickly replace a lot of people with this. I would probably watch and be more cautious. But I think that the pressures are definitely, like I'm hearing more people who seem more willing to push to deploy these than I would have expected. So yeah, I think there is a disconnect between people feeling like they have to make decisions now and people actually having full information that they need to make those decisions.
So it's interesting you should say that, Ellie, because I was with some security leaders last week, and we were talking about just this challenge, this balance that you have to strike between releasing technology, if you like, slightly early, without fully knowing perhaps what it is going to do. And certainly there was a very interesting debate that we had about just when do you know something is mature enough? And we got into ChatGPT as a particular case study, if you like. And what I found interesting was again this complete split where some people who were taking the view that ChatGPT could only help in terms of the way that things were developing. So they tended to be on the business side. So marketing, for instance, yes, we can get things to market very much more quickly in terms of collateral and materials and so on. And then on the other side, security in particular is saying, well, hang on a minute, to the point you were making earlier, what can be used for good can also be used for bad. And we mustn't forget that the bad guys have access to all of this tooling and technology in much the same way as we do. So I think that debate is going to go on for some while. But let's dig into ChatGPT in a little bit more detail, because we've mentioned it a few times now in this podcast. Is this an example, do you think, of a tool that perhaps was released too early? Should it have been kept away from the public for a little bit longer and tested further? Or what's your take?
Yeah, that's a great question. So I was just talking to someone about this yesterday, and I think my feeling, I have like somewhat of a nuanced answer. So I think like my short answer is no, I don't think so yet, right? Like the way it's currently released, which is like it's sitting there on OpenAI servers, people can play with it, they can ask it whatever, and that's all it's doing. I think this is a good time for it to have been released. Basically, like I said, I think this technology isn't, if it had only been released within academic circles rather than having been released to the public, it would have made a little bit of a splash, but not significantly more than about every 6 months, some model has come out within academic circles and made a splash. It's better. And we've been kind of plodding along on this trajectory since 2018. And so it would have been like, oh, this is exciting, but it wouldn't have, like, it would have been like meaningful, but not that meaningful. But releasing it to the public, it was like a huge moment because the public hasn't been paying attention to all the little ones that have been released along the way. And I think the really good thing about releasing it now is it's forcing these bigger conversations that were happening a little bit in academia. There's been groups that have been like really talking about, but it's not really academic computer scientists' main forte to talk about these types of things. So it is conversations that the public should be having, right? And I think having the models out there is getting these conversations. So I think right now, the way the models are currently released, where people can go and play with them and stuff, I don't think there's huge risks of that. What I would feel like is too early is if every company started integrating it into little nooks and crannies within their business. Like I think that wide proliferation does make me a bit nervous because I think that's where suddenly the risk of things going wrong would become much, much greater. And I think the security analogy is nice. Like you can just think about like how much more the risk of something like identity theft or some problem like that is when you have like thousands of accounts on every tiny thing. You have to have a password and a username and an account for like every time you buy like a product or something. And so just like every single one of these companies is not going to have the top of the line security, and you just run these types of risks. And I think the same thing would happen with generative AI. If just everyone starts using it before we understand it super well, we're going to get this fairly rough period, a pretty painful learning experience, right, of all of these things going wrong. So I think it hasn't yet been released too early, but I can imagine like a year from now, if everyone starts deploying it really widely, that might be too early, in my opinion. I think it also depends, like you were saying, there's kind of mixed feelings from the business side, from the security side. Like there's all kinds of different use cases for it. And companies are talking about everything from like using it to pre-populate internal reports to having it as a customer service chatbot that can like make changes to users' order histories to, mining drug databases to discover new drugs. Like it runs the complete gamut of every possible business thing. And like some of those are going to be higher risks than others. Like some of those are easier to put in some little sandbox thing where it really doesn't have access to much stuff, and the worst it can do is pretty minimal, to it has some hook into deep parts of the company's data or security systems or something where the risks are much higher. And so I think that it's hard to say in a blanket statement like no one should be deploying generative AI in their companies. But this is what we're saying, like the people who have enough expertise to really understand which of these are higher and lower risks, I think those people might not exactly exist yet. So you're going to be dealing with decisions by committees with a lot of consulting, which is not the wrong way to do things. Like that's how stuff happens. But like we all also know that there can be leaks in those kinds of processes. So to me, the kind of widespread deployment is the thing that would be too early. And it hasn't really happened yet, but people are talking about it. And I would feel comfortable if that held off for a couple of years, right? I don't think it's likely to, but I personally, if it was up to me, I would say let's wait 3 years and then check in, see how things are going.
Right. I mean, certainly, I think one of the things that has always concerned me from a security standpoint, not just about AI, but about data integrity in particular, is that as we increasingly make decisions that are data based or data driven, we really have to make sure that the integrity of that data is where it ought to be. Now, if we put that into an AI type environment, we're supercharging potentially some of those errors and some of those mistakes. And so, it's interesting hearing you say, maybe we should have waited a little bit longer or should wait a little bit longer. Because for me, the essence of it is, can you actually trust some of the outputs that are being produced? Because if you're going to be making decisions, and that could be in the medical space, it could be just in terms of where you're going to develop new product. So a whole range of different things we can talk about there. But if you are going to be making those sorts of decisions, then you have to be absolutely certain that you've put the right stuff in, because otherwise you're going to get the wrong stuff coming out, to put it that way. Any tips or advice or things that you have seen that people would find useful, perhaps, in terms of how to ensure or just double check that the basis upon which generative AI or AI is making its decisions is good, is solid? Anything that people can do there?
So I'm glad you asked that question because I think that helps kind of point to some of the stuff that, like when we talk about how mature is the technology, I think this is a good example of showcases how immature it is, right?
Right.
Just from an understanding standpoint. So like, we've been having discussions as a society about data-driven decision making well before generative AI, like the Weapons of Math Destruction book, right? Like that kind of discussion has been happening. And those are with kind of earlier machine learning models that we have much better theoretical understanding of. And so there's been a lot of work on, and the really classic examples are like credit lending decisions are one that has had a lot of AI in the loop, and has been shown to have systematic biases against races and people from low income backgrounds, things like that. Similarly, criminal justice, right, is a really
Right.
common one where there's been a lot of discussion about the ethical use of machine learning in those contexts. And so there's a ton of scholars working on these kinds of problems and trying to come up with ways to, like working with policymakers to say what are the kinds of things that we would consider fair or just okay, and how can we kind of like guarantee that the model actually aligns with our definition there. And when you talk to those people about generative AI, they're like, I don't even know how to approach it because the models are very different, such that we don't have the same kind of theoretical tools for reasoning about them that we have for the traditional models. So that kind of puts us in this difficult thing where one way of doing it, which is a kind of common way, is something like disparate impacts type of decision, which is like you get a ton of models. Like you don't actually care about the process the model used under the hood because we don't understand much about what's happening within a generative AI model. And you just look at a ton of the decisions over a long time horizon and you say, have there been systematic problems that we've noticed, right? So something like a medical decision, have we found that it's over or under diagnosing certain subgroups of patients or something like that, or certain diseases? Is it making things that are unfair financial decisions? Like you would need to look at that over a large number of decisions. So that's like one way of kind of doing it. It's more of a policy than a technology question. But the problem is even just like simulating that in practice, right? So I think and this is again where it's like we should slow down a bit. You would basically need to be running it in parallel to this current system for several years, collect all of the data, and then after, say, 3 years, say, what did the human doctors say? What did the AI say? Where did they agree? Where did they disagree? And like do kind of a post hoc analysis of whether it had problems, right? So that'd be kind of like one way to maybe vet that we trust it, but it still has this kind of black box flavor to it. The other way we tend to want to think about systems and say, like, what features did it use to make its decision? When it makes this diagnosis, why did it make that diagnosis? And that, I know a ton of people who are working on this, on generative AI models, all kinds of approaches, but there really isn't a consensus on what it means to even ask that question, right? Like we're still arguing about how the model is representing things under the hood, how we can tell what it's using. So there's just a lot of basic science research that needs to happen for us to do that well. There's definitely tools that appear to do it, but they're far from like ones we deeply trust. So I can imagine if we kind of go with the technology we have right now for like the model producing a rationale for why it did what it did, there's a good chance in a couple of years we'll find a fundamental problem with that system and we'll be like, oh, it was providing rationales that were basically telling us what we wanted to hear and had nothing to do with its underlying decision making. Like that's the kind of problem that could arise. So there's just a whole host of just really basic challenges with trying to make these kinds of guarantees with the models. I know a ton of people who are working on it very actively. I would say 3 to 5 years will have made a ton of progress. But like right now, if I had to deploy a system right now, I just couldn't tell you how to do that with a reasonable degree of certainty, feel like you could trust that you understood why the model was making the decision it was making.
Ellie, I think that's probably a good place for us to leave it on this particular podcast, because not knowing where we go next and having to give it a little bit more time sounds to me to be eminently sensible. But, I have to declare I do come at it from that security standpoint where we're not going to rush into some of these things if we can at all avoid it. But Ellie, thank you very much indeed for just sharing some of your thoughts. We touched on a whole range of different areas there, from regulation through to just the maturity of the technology. Clearly a very, very exciting space to be working in at the moment. And thank you for sharing your insights.
Thank you so much for having me, Steve.
Special thanks to this week's guest, Dr. Ellie Pavlick. We'll be back with a new episode next week. In the meantime, if you would take 10 seconds to pull up this podcast on whatever device you're listening, give us a 5-star rating and write a quick review, we'd be grateful. You can also listen to the ISF Analyst Insight podcast, which goes in depth on the hottest topics in information security. In every episode, ISF analysts hand-select active security professionals from ISF member organizations to discuss how the implementation of ISF research is uniquely applied to their real-world context. We hope you'll listen, and of course, we'll put a link to that show in our show notes. If there's a topic or question that you'd like us to cover in a future episode, let us know at securityforum.org, which is also where you can find our catalog of past video and podcast episodes, as well as ISF's research, practical tools, and guidance related to discussions like today's. The ISF podcast is produced by Talkbox and Tavia Gilbert, with senior producer Katie Flood. Mix and master by Kayla Elrod. Music by Alexander Filipiak. Thanks for listening.